All right, we're talking about exponential functions. And it says an exponential function is a function of the form y equals a times b to the power of x. And a couple things here. You have to know that a and b have to be bigger than 0. They cannot equal 0 or we wouldn't have an exponential function. And your b value cannot equal 1, and we'll talk about why that is in a little bit. So exponential functions are nonlinear, which means they do not make a straight line. They actually create a curve. So they are a curved graph. And we have two types of functions. We either have an exponential growth, which would kind of look like this, or we would have exponential decay, which would look like this. And if you're just given an equation, you can look at the equation y equals a times b to the power of x, and if your b value is greater than 1, then your graph should be growth. And if your b value is between 0 and 1, which means it's a fraction or a decimal, usually it's written as a decimal, then it's decay and it's going smaller than 1, okay? So it's going down. Now in both of these, this y-intercept is actually the a value. Okay, that's your y-intercept on both. So no matter if it's going up or going down, that's your a value, which we know as our y-intercept. Okay, which is right here in your equation. It's the first thing you see after the equal sign. And then the other thing that we need to talk about is that your graph will never, ever, ever touch this x-axis. Okay, it will get very, very close to it, but it will never touch it. So if you think about a piece of paper, and so I'm going to pull the piece of paper here. So I have this little piece of paper. And if I were to rip it in half, I've made my paper smaller. So I'm going down, I'm getting smaller. And if I rip it in half again, it gets smaller and smaller and smaller. But it never ever disappears. So even if I keep ripping this in half, it's going to keep getting smaller, but it will never disappear. And so that is why my graph will never touch the x-axis. And the x-axis has an equation, and that equation is y equals 0. So the x-axis is y equals 0. So what we should write over here on the side of your paper is that the graph will never touch the x-axis, and the equation for the x-axis is y equals 0. Okay, same thing here, it's never going to touch the x-axis, which we know is y equals 0. All right, on both of these, we're going to come down here and we're going to talk about domain. Domain is all of your x values. So what's my graph doing from left to right? And so here it goes to left forever and it goes to the right forever. Also on the decay function, it goes to the left forever and it goes to the right forever. So my domain is all real numbers. My range is my y values. My y values are never going to be negative, and they're always going to go up. And the smallest they can get is to 0, but not equal 0. So my range, my y values, that's the up and down part, is y is greater than 0. I can be bigger than 0. I can never touch 0. We already talked about the y-intercept. We said the y-intercept was the a value, or the starting value. And then asymptote. The asymptote, the definition that we're going to use for asymptote is a line that the graph can never touch. Okay, so a line that the graph can never touch, we talked about this. The asymptote for our exponential functions is y equals 0. And that's for both of these. Okay, the graph is never going to touch y equals 0. Okay, on the back we have some word problems, and this will help put everything into perspective. And I say that, and before I even move forward, I forgot to talk about these two equations. Growth model. So y equals a times 1 plus r to the power of t. And so it's like saying y equals a times b to the power of x, where your b is that 1 plus r. R is your growth rate. And our growth rate is usually given as a percent, and we have to change it to a decimal. T just represents your time, and so if you want to use x or whatever variable, that's fine. And then a, we've talked about this a whole bunch of times already, that a is your initial value. On the decay model, it's the same thing. You'll see y equals a b to the power of x, but your b is going to equal the 1 minus r. And r, again, will be your rate, and we'll have to change it from a percent to a decimal. So now let's look at the word problems. It said the painting is sold for $1,800 and its value increases by 11% each year after it is sold. Find the value of the painting in 30 years. So A is your start, and here we are starting, the painting is sold for $1,800. So that's our starting value. Our rate is 11%. And then T for time, we are measuring time in years. So if I want to change a percent to a decimal, I move the decimal 2 places to the left. For example, if I say 37%, my decimal is currently invisible, and I move it to the left 2 places, and it becomes 0.37. Okay? So here, 11%, we're going to write this as a decimal, and so I'm going to move it 2 places, and it becomes 0.11. We cannot put percents into our formula. So our equation, I also need to know, is it growing or is it decaying? And it says my value is increasing. So my equation is the growth equation, which is y equals a times 1 plus r to the power of t. And 1 plus r is your rate. So I'm going to rewrite this now, and I'll put in my numbers. So y equals, well, we started with $1,800. And then 1 plus, my rate is 0.11 to the power of t. And all I want to do is figure out what 1 plus 0.11 is. That will help me write my actual equation, because this is how you will see it. Y equals 1,800 times 1.11 to the power of t. And if I had just typed that in the calculator, that's what it would give me. So on this one, I just want to sketch my graph. I know that my graph is growing, it's increasing, and it's going to start at 1800. And then it's going to go up. And that's my sketch. So my reasonable domain would be my x values, but my x only goes to the right forever, and it starts at 1800. So my x this time is greater or equal to 1800. Oops, sorry. My x is the 0. It's time, it's 0. My x is greater than or equal to 0, because I start here and I get bigger. My reasonable range is what I had said before. My range is my y values. That's what's going up. And my range is y is greater than or equal to 1800. Okay, because the value is going to increase. What does the y-intercept, or what is the y-intercept and what does it represent? So remember, my y-intercept was my starting value. If I were to write it as an ordered pair, it would look like this. And it's the initial value of the painting. And then to figure out how much it would be in 30 years, we would type this into the graph page and press menu 5-1. And we would type in the value of 30 to figure out what the y value is. Okay, we're going to skip that part for right now, and we're just going to go down to the second equation, or second problem. So example 2, the value of a car is depreciating at a rate of 5% per year. In 2010, the car was worth $32,000. Find the value of the car in 2013. So I just want to focus on, can we write this equation? And so A is your initial value. So we're going to start by talking about when it was in 2010, the initial value was $32,000. And then my rate is the 5%. And so we change 5% by moving the decimal 2 places, 1, 2, and that would give us 0.05 as a decimal. And my time, I'm still measuring it in years. And am I growing or decaying? And so this word depreciate means that I'm decaying. So we need the decay equation, which is y equals a times 1 minus r to the power of t. And I'm getting these from the front. But you just need to remember it's either 1 plus or 1 minus. So if we were to fill it in, y equals 32,000 times 1 minus 0.05 to the power of t. And then to write it a second way, we just figure out what this part equals. So if I were to say 1 minus 0.05, that equals 0.95. And so my second equation would be y equals 32,000 times 0.95 to the power of t. And so since this is a decay function, it's going to start up here at the top at 32,000. That's our starting point. And it's going to decrease in value. And the graph would look like that. My domain still starts at 0 and gets bigger. So x is greater than or equal to 0. And my range is decreasing from 32,000. So my range is y is less than or equal to 32,000. But remember, we said that it will never ever equal 0. So I also have to say that it is greater than 0. And we write it backwards. So y is greater than 0. The y-intercept is 0, 32,000. And it represents the initial value of the car in 2010. Okay.